Currently, renewable energy sources are gradually becoming popular around the world, especially solar energy. To be able to use this energy source, solar panels are indispensable. In this video, join me in exploring a factory that mass produces solar panels. The main raw material for solar cells is silicon, mined from quartz ore or sand. To be able to produce solar cells, silicon needs to be purified. The pure silicon is then grown into large blocks using the Czochralski method. This method helps create high-quality silicon crystals qualified for battery cell production. Once formed, the silicon block will be cut into thin slices called silicon wafers. The thickness of these silicon wafers typically ranges from 180 to 220 micrometers. After cutting, the silicon wafer is cleaned with a chemical solution to remove dirt and impurities. The wafer is then coated with an antioxidant layer to protect the surface during the manufacturing process. This cleaning and surface preparation process is important because any remaining impurities can affect the battery cell's performance. Next, the doping process will take place to create semiconductor layers with different conductivities, forming an important PN coupling for solar cells. The silicon wafers are then coated with thin metal layers to form collector and generator electrodes. This process is very important because it determines the photoelectric conversion efficiency of the battery cell. After having complete battery cells, to produce large capacity solar panels, these battery cells will be connected together in a specific configuration. This process begins by connecting the battery cells with metal wires. These wires help create electrical circuits, allowing electricity generated from sunlight to be transmitted efficiently. Depending on the capacity of the battery panel, there will be different numbers of battery cells. After the battery cells are connected together, they will undergo a visual inspection. This inspection ensures that the battery cells and connections are undamaged, have no visual defects, and that the electrical connections are solid. Ensure that the metal conductors are securely attached and there is no poor contact, which can lead to reduced performance or future failure. At the same time, in another machine, the robot is picking up tempered glass panels onto the machine to get ready for the process of assembling battery cell modules together. Tempered glass will be coated with a layer of AVA before assembly. This AVA layer plays an important role in protecting battery cells from environmental and mechanical impacts, while enhancing the durability and stability of battery cells. Next, the robot automatically picks up the battery cell modules on the glass plate, ensuring the correct number and position of the cells. The robot's precision helps ensure each cell is placed in the right place, optimizing solar panel performance. This automatic machine has a fixed task, ensuring that the battery cells do not move when moving to the next step. Before applying the next layer of AVA, the board will be thoroughly inspected again. Technicians will use state-of-the-art measurement and testing tools to ensure that all battery cells are in place and free of any defects that could affect performance and durability of the battery panel. In this machine, the final layer of AVA and the base plate will be completely attached to the battery plate. To increase sturdiness and protect solar panels, the next step is to add protective aluminum frames. Aluminum frames not only help increase the mechanical strength of the panels, but also make it easier to install and fix the panels in solar energy systems. After installing the aluminum frame, the connection ports of the battery panels will also be completed. The connection port is an important part that helps the panel easily connect to the electrical system, transmitting electricity from the panel to energy storage devices or systems. These connectors are usually made from materials that conduct electricity well and are designed to be water and dust resistant, ensuring high performance and durability. Before being released to the market, solar panels must go through a series of strict tests to ensure that they are of the best quality when they reach consumers. Hardness tests of solar panel glass are essential to ensure that they can withstand harsh weather conditions such as hail, windstorms, and other environmental factors.